Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 59 of Physics 5054. Yesterday we did 4 questions in the exercise, and today we are going to start question number 5 of section B, which is all about the structure question. The question is saying that account for the following. Number A saucepan used in cooking has a low heat capacity. Yes, a saucepan used in cooking must have a low heat capacity because we need quick rise of temperature for cooking. So if the material used is having high absorption power of heat, so it will not reach quickly to the required temperature for cooking. So the material used inside the saucepan is always having low capacity of heat. A very less amount of heat is absorbed by the a saucepan, and the remaining is given to the food which we are cooking. So for that particular purpose, saucepan is using a low heat capacity material such as iron or steel. Number second, saying on a clear sunny day, the temperature of the surface of the sea rises less rapidly than the temperature of the nearby land. Ladies and gentlemen, when the sunlight is going to enter the surface of the sea, because of its huge mass, it is having large heat capacity to be absorbed by the sea, and that is why the temperature is less rapidly rising. While on the other hand, if there is earth whose temperature is rising very quickly because it is having low heat capacity, uh, so a low heat the earth will absorb and the remaining will be given to the environment. So in both cases the heat capacities are playing the role. In sea, large heat capacity is there, so it is absorbing large heat, and less rapidly the uh, temperature is rising on the sea surface. On the other hand, earth is having low heat capacity, so it means that the temperature near the surface of the earth will rise very quickly. I wrote all these points for you people so you can note down it in your copy. Now we are coming to question number 6. Question number 6 is saying that a gas burner is used to heat 0.50 kilogram. So it means mass is given as 0.05 kilogram. And what further they are saying, that of water in a beaker, the temperature of the water rises from 15 degrees Celsius to 60 degrees Celsius. It means that the temperature which we are denoting by delta theta is equal to 60 degrees Celsius minus 15 degrees Celsius, which is equal to 45 degree Celsius. When we subtract that, we will get the uh, 45 degrees. Further, the question is saying that in 60 seconds. So T is given as 60 seconds. No need to convert it because already the standard unit is given. If it was in minutes or hours, we had to convert it. Assuming the specific heat capacity of water, small c, is equal to 4000 joule per kilogram per Kelvin. What they want? They want to calculate the average rate in which at which heat is transferred to the water. So rate means that we have to find power. The rate at which energy is transferred is called power. So we have to find this power. We know the formula, and that formula is we are having specific heat capacity is equal to 1 over m and p cross t divided by delta theta. We have to find the p, so we have to make p as the subject. Here it is given as 4200 and 0.50. P we have to find, and T is 60 and delta theta is 45. So we can write, ladies and gentlemen, P is equal to 4200 multiplied by 0.50 multiplied by 45 whole divided by 60. And when we use the calculator and find the values, so it will be 1575. And what is the unit? So in this way we can find these power. Now we are going to do question number 7. And question number 7 is saying that a low voltage heating coil which has a resistance of 3 ohm. So here we have to write the data. Resistance is the opposition provided by the lattice atom in a wire to the flow of electron. So this is a symbol for ohm, which is the unit of resistance. Further, they are saying that which has a resistance of 3 ohm is connected to a 12 volt battery. So V is equal to 12 volt. Now, they are saying calculate the rate at which heat is produced, means that we have to find P. Ladies and gentlemen, first of all, we have to find I. So, from Ohm's law, V is equal to IR, and I is equal to V divided by R. Now V is also given, and that is 12, and R is also given, which is 3. So when we divide it, 3 ones are 3, 3 fours are 12. So 4 ampere will be I. Now everything is ready for power. So P is equal to IV. Yesterday we also discussed, and we will discuss this in the upcoming chapter of electricity and magnetism. Now we have to put the values inside this. I is we found it is 4 and V is 12 volt. So it means that 48 watt is the ultimate answer of the first part of question number 7. The heating further in this question, this is not a new question, they're not given the part, but I am giving the parts to it. So let us do the second part in this particular area. Remember that they not given label 1. This is one question in continuation. The heating coil is placed in 0.20 kilogram of water. So it means it is referring to the mass, because from the unit we can understand that it is mass and that is kilogram. Further they are saying which is in lead container of negligible heat capacity. Calculate the time taken. We have to calculate the T, the time taken for what? The time taken to raise the temperature of water from 16 to 40. So delta theta means from the final temperature we have to subtract the initial temperature, and initial temperature uh, is given as 16 degrees Celsius. So it will give us, when we subtract this 4, and that will be 46 degree Celsius. So all the data is given, one thing is remaining, they given us is a point that takes specific heat. Without seeing it specific heat of water, if you remember, I told you in one of my previous lecture that if they given you the value, it is okay, but if it is not given, then you have to memorize that 4200 joule per kilogram per Kelvin is the value of specific heat of water. That is a very famous value of the water. So you have to at least keep this in mind. Now because we are finding the T, so we know that as C is equal to 1 over M, and here they given us P cross T, which is equal to T as well. So then we are getting delta theta. Ladies and gentlemen, one question arises in the mind, that why we are writing P cross T, why we are not writing Q? Because remember that P is equal to Q divided by T, and Q is equal to P cross T. We are not writing Q for two reasons. One reason is that they given us P, no Q concept is there. So if we are writing Q, from where we will take the value 1. The second thing is that we are going to find T, and if we are writing Q, then from where we will find this T. So these are the two reasons that we are writing P into T. Ladies and gentlemen, now we are putting the values. 4200 is equal to 1 divided by 0.20 kilogram. P We found 48 in the previous part. T we have to find, so we are keeping as it is. So we are putting 40. This is 44, not 46. So we are writing 44 here. Everything is there without T, which we are going to find. So T is the subject. 4200 multiplied by 0.02 multiplied by 45 whole divided by 48. And when we calculate it, so it will be equal to 420 seconds. 420 seconds will be the ultimate answer of this question. Ladies and gentlemen, now I am coming towards the last question, and that is the question number 8. But because there is a diagram inside it and I don't want to waste your time, so I will erase the whiteboard and make that diagram and then we'll come back. Wait. Okay, we are back, and question number 8 is saying the figure shows an arrangement which is to be used to determine a value for the specific heat capacity of a liquid. Whatever liquid is that is unknown, I denoted that liquid with the dash dash lines, and we have to find what? We have to find the specific heat capacity of this liquid. There is a heater immersed inside this liquid, and it is denoted heater, which is heating up the liquid. To heat this water up, there must be an arrangement for the heater to work. So there is a 12-volt battery which is connected to meter number 1, and then it is connected to meter number 2, and this is the variable resistance. When there is a line on this value, so it fixed resistors are denoted like this, but variable resistors are denoted by putting a pointer on the box. From this arrangement that took the two branches of that heater which is connected here. Now this will heat up the water, water or whatever. They're not given us that this is a water. Liquid can be anything. So generally we are saying liquid. Okay, we discussed the arrangement. Number A part, they are saying that what quantity is measured by each of the meter M1 and M2. This is M1 and this is M2. So what quantities they are arranging? They given us this question before time, but let me explain it. There are two things which must be connected to the battery either in series or in parallel. So remember that volt meter is always connected in parallel because of its high resistance. Because of its high resistance. If it is connected, if it is connected in series, then we will not be able to measure the voltage. Why? Because of its high resistance. On the other hand, ammeter is always connected in series, always connected in series. This is one thing. The second thing you have to keep in mind, voltmeter is used to measure the potential difference. The potential difference, or you can say voltage. Voltage is in AC and one is in AC and the second one is in DC. Potential difference is in AC and voltage is in the AC. Okay. Ammeter is a device used to measure the current. Ladies and gentlemen, this is not the part of the question, but let me give you another information, and I am writing that in red. Galvanometer is a device used for the detection of current, not measurement. Remember these things. So you got enough knowledge about the devices. Now this is in series. This is in series, but that is in parallel. So M1 is used to measure the current, while M2 is used to measure the voltage. We can understand that for their connection in series and in parallel. We will discuss these concepts in greater detail when we reach to the topic of electricity. And that is why I told you that they given this part a bit earlier than that. Okay, that was the whole story about part number A. Now we are going to find the answer of part number B. In part number B, during the experiment, a large amount of heat is lost from the surface of the liquid. Number one part in B, they are saying that describe two processes which could be responsible for this loss of heat. I am writing conduction is a process which is used to lose a huge amount of heat, and thermal radiation. Thermal radiation. Let me explain it. Ladies and gentlemen, when this heater is heating up the molecules in the middle, they are moving then to the sides of the container, and when they reach here and here, they are going to the outer edge of that container. Because this is a glass and glass is a conductor inside, the glass is hot due to the collision of these molecules, but from outside the glass wall is cold, and you know that heat always flows from hot body to the cold body. So this heat will go to the environment due to thermal radiation. And second is that the molecules which is moving to the top surface of this liquid, they will lose their heat energy very quickly. So there are two methods. We are not going in the evaporation, because evaporation can also be used. Convection is also used. Conduction is also used. Radiation is also used for the energy transfer. But because those are the topics of next chapter, so we are leaving those things for the next chapter. Here we are remaining in the context of molecular theory, kinetic molecular theory of matter. So these molecules are moving to the sides, and through this glass they will, due to thermal radiation, will transfer the energy from inner of the container to the outer environment. And the top there will be another process due to which they are due to conversion in the steam. Okay, that was the whole story about the first part. The second part of question number B is saying, suggest one way in which loss of heat could be reduced. So one way is that you have to wrap around an insulating cloth, cover the outer edge, cover the outer edge with the help of insulating fabric. The second one also I am telling you that from the top cover it with a lead. So if you are covering this with an insulating cloth and from the top if you are covering it with the lead, so it means that the transfer of heat from the liquid to the environment will have a lesser chance. Okay, now C number part. In the experiment, it took 300 seconds. C part. T is given as 300 seconds to increase the temperature of 0.10. So M is equal to 0.10 kilogram of mass the liquid from 25 to 50 degrees Celsius. So delta theta is 50 degrees Celsius minus 25 degrees Celsius, and we will get 25 degrees Celsius as the result. Now they are saying, and the apparatus was losing heat at an average rate of 12 at an average rate of 12 joule per second. So Q loss, I am writing loss of heat is equal to 12 joule per second. Remember these things because we will need it. And then further they are saying the energy supplied to the heater was 1300. So Q is equal to 13,600 joule. That is another thing we have to keep in mind. Assuming the heat capacity of the container can be ignored, calculate the value for the specific heat capacity. So we have to find the value for specific heat capacity. So as C is equal to 1 divided by MQ divided by delta theta. So because we are finding C, so it will be 0.10 into delta Q is very important. 13,600 minus, because they are losing the 300 second, so 12 multiplied by 300 seconds, and delta theta they given us to be 25 degrees Celsius. Now one question is this one. They told us that they are losing 12 joule per second for how much time? For 300 seconds. So we have to multiply this 12 with the 300 and we will subtract that from 13,600 because they went out from the system. So as a result, we will get what? We will get 10,000. So C is equal to 0.10 into 10,000 divided by 25. And when we calculate it, we will get 4,000 because this is 10,000 divided by 2.5 when we multiply these two quantities. So 4,000 joule per kilogram per Kelvin will be the answer. Now very quickly, because we are running out of time, in the experiment D part is saying that in the experiment using a larger current would increase the temperature more quickly. If you are giving more current, it will increase that, and that is very important. Why would this lead to more accurate value for the specific heat capacity? If we are slowly increasing, if we are slowly increasing the temperature, then on one hand it will provide heat energy, but on the other hand it will lose energy as well. Remember, ladies and gentlemen, that if we are giving heat, it will increase, but on that side, the heat will go. So, if it is in rapid succession, so if we are increasing the current, more heat will be produced, and this will not allow the molecules to lose their energy quickly. So if we are rapidly increasing the current, so it means that more accurately we will measure the heat capacity of that liquid. Ladies and gentlemen, that's it for today. Thank you. Allah Hafiz.